Welcome to an algebra tutorial video digging into linear equations, thinking about a relationship between two variables. In particular, but we're going to look at graphs as well. How can we show this linear equation relationship with a nice picture? So let's take a look at this problem here. We got a context and we're going to put together a linear equation based on this context and then graph it and see how the graph and the equation and the context all relate to each other. So we got a bicyclist. He starts off 50 miles away from his home and travels back to his home at a speed of 15 miles per hour. Okay, we know linear equations always fit this format, y equals mx plus b, where b is our starting value or our constant term, and m is what we're repeatedly adding over and over and over again. And then x and y are variables. We want to see how they're related. So in terms of translating this problem here, we know we're starting off 50 miles away. So there's a point, a starting point, and from there, I'm traveling back to my home at a speed of 15 miles per hour. So if I'm translating this thing into an equation, let's define our variables. I'm going to say x is the amount of time. I want to see as I'm traveling, however long I take, my distance is going to change. So x is going to be the number of hours traveled. All right, we can see the number of hours because again, all of our speed is related to hours. So I'm going every hour, I'm going another 15 miles. So hours makes the most sense to define a variable. Okay, as I'm traveling, as I'm going a number of hours, what is that going to affect? What do we want my y variable to be? So my y variable in this case is distance, but not just any distance, the distance from his home. So he's starting off 50 miles away and then traveling back to his home. The thing I want to keep track of is, well, how far is he from his home? All right, let's put together our equation then. So the distance our biker is from his home is equal to, he starts off 50 miles away, so I'm going to put that in for B as my starting value, but then he's traveling back to his home. It may seem like I should put 15 in because he's going 15 miles an hour in for m, but I'm actually need negative 15 because he's getting closer and closer. His distance should slowly get down to 0 and decrease as he travels more. So I'm going to put in a negative 15 because the distance is going to decrease by 15 every hour. And then x is the number of hours. So there we go. I'm 50 miles away right now, but every hour I travel, I'm going to be another 15 miles closer and eventually get home. Okay, so there's my linear equation. We got our value for b right there. There's my value for m, and it's directly relating my x and y variables together based on this equation. Okay, but now I want to figure out, well, how can I make a picture of this? I got this nice equation. I want to graph it. Let's think about how we can do that here. So I'm going to use some values. Again, x, all this axis is just going to show are the values that I have here. So we can find out as x is 1 hour, as 2 hours, as 3 hours. I'm going to pick some x values, put them in, find some y values, and it's going to give me some points that I can graph. So let's start with x is 0. If x is 0, I'm going to put 0 in. I'm going to get y equals a negative 15 times 0 plus 50. Well, negative 15 times 0 is 0 plus 50 means y equals 50. And so we have the point 0, 50. And I'm going to plot that on my graph right here. All right, let's do another one. What if x is 1? Well, my y value is equal to negative 15 times 1 plus 50, which is 50 minus 15, which is going to be 35. So my next point after he travels for 1 mile or 1 hour, he's only 35 miles away from home. So he goes for 1 hour. I'm going to find 1 on my x-axis. Now he's only 10, 20, 30, 35 miles from home. So he's a little bit closer. He's a happy guy. Let's do one more. X equals 2. So after 2 hours, he's traveled negative 15 miles an hour for 2 hours plus 50. It's going to be 50 minus 30. It's going to be 20 miles from home. So writing down my point, if he travels for 2 hours, now he's only 20 miles from home. So let's find that 2 hours. Going to find 2 along the x-axis and 20 along the y right here. We'll plot that point right there. Now you'll notice they're in a nice straight line, right? We could find one more. If I go x equals 3, I could run through the math, but you probably already figured out I just need to subtract another 15. So after 3 miles, after 3 hours, he should only be 5 miles away. So 3, 5 would be right about there. And again, it follows my nice linear pattern. It's a linear equation, the constant rate. I'm decreasing by the same amount every time. Let's draw a nice little line now to show his change. So there we go. I've just graphed my relationship. I could make my arrows, and in fact, if we had a general linear equation, if we were just graphing this, I'd make my arrows and go all the way. But I have a context of a bicycle, so going negative hours doesn't make any sense. So I'm not going to graph it along there. And then being a negative miles away from home doesn't make any sense either. So this particular context, I'm only going to graph this specific part right here for the values that make sense. But there you go. Again, some things I want to point out. Notice how I started right here at 50. It makes sense because 50 is my starting value. It's where we start right along the y-axis here. So these points, that point along the y-axis needs to match up with whatever value my b value is. So as you're graphing, find that value for b, that constant term all by itself, and your graph of your linear equation has to cross the y-axis right there. Now with my m value, the thing that I'm constantly doing, I'm subtracting 15 over and over again. We can see that in my graph because every time I change 1 unit along x, I go over 1 unit, what happens? We subtract 15. I'm going down by 15 right there. If I go over another unit, so another hour goes by, I subtract another 15 miles. If I go another hour, I subtract another 15 miles. This pattern where we're decreasing or adding, we can see that in my graph over and over too. Every time we change 1 along x, I should see whatever value for m here changing along my graph. And here we can see, yep, I'm going down by 15, subtracting 15 every time I go 1 hour. So hopefully that helps draw the connections between our equations that we're writing to represent linear situations and the graphs that we can do to show the relationship between our x and y values.